What's up, everybody? This week we're going to be working with the tone function, and we're going to start making some music with our Arduinos and Tinkercad. So we're going to talk about the base code today. We're going to talk about the tone function, and ultimately you guys are going to be turning in Twinkle Twinkle Little Star to me. So once again, today we're going to learn about the tone function, copy that base code, and we're going to get a familiar tune like da 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 da. I don't really know what that's called, so I'm just referring to it as a familiar tune, but that's going to happen right there off the get-go. And then we're going to modify the code to play Twinkle Twinkle Little Star. So what's going to be due next week? Your Twinkle Twinkle Little Star song is what's going to be due. Okay. So first of all, tone is a function that's built into the Arduino system. It generates a square wave, okay, which is the same sort of wave that like a PWM wave is, or any sort of digital wave. Um, and we can use that to connect a piezo speaker, which is like a little buzzer. A lot of electronics make noise with piezo speakers, and we can play tunes with it. Okay, now the Arduino is not a musical instrument. All right, we can't be playing really complex different songs. We can only generate one tone at a time within the Arduino. So again, you can't create like a symphony with this whole thing, but you can create some basic tunes. We can't use pins 3 and 11. Honestly, we're going to all be using pin 8 anyways, but they get in the way of the PWM output. And we can't generate tones lower than 31 hertz, which is a pretty low bassy song anyways. And all this information is coming from the arduino.cc website here. I just copied it. You're welcome to click on the link in the bottom to take you for more information there. So when we start talking about this tone, we're going to be using this bottom one here, where we're going to refer to the tone. Okay, and we're going to say what pin number our speaker is connected to, what frequency we want to play on that speaker itself. Okay, what note that is, and then the duration, like how long that note is going to last for. So the frequency is going to be in hertz. The higher the frequency of a sound, the higher the sound is. Okay, and also the hertz, the frequency itself is how many times it oscillates within 1 second. The higher the hertz, the higher the sound. For the duration, that's going to be in milliseconds. And it says optional, but that is what we're going to be using, and we're going to talk about that. And again, this all comes from the Arduino website, and the source is down in the bottom right. So the first thing we're going to do here is we are going to copy the code, okay? And the base code can be found here, which we'll shoot to here in a second. We're going to copy the code into Tinkercad, and we're also going to insert pitches.h code into the main body, which is different than that on the website. And the website, it talks about creating like a new tab within the Arduino IDE and inserting all the pitches.h code into that. We can't do that in the Tinkercad software, so we're going to do a minor workaround here. So as it says here, this is different on the website, so check my video for more information. So let's open up this real quick here. So first of all, when we jump into the Arduino website here, it tells us how we're going to connect up our piezo speakers. We're going to take a piezo speaker, we're going to connect that to our Arduino. Our positive wire is going to connect to pin 8. Our negative wire is going to connect to the ground pin. All right, so when I go into my Mighty Circuits, I already have my Arduino in here set up. I'm going to scroll down over here and I'm going to find the piezo speaker. Okay, and if I wanted to rotate that piezo speaker so it looks basically exactly like it does, oh geez, I missed it again. Exactly like it does in the Arduino, I could rotate that. So when I connect up my wires here, this is my positive wire, so I'm going to bring this to pin 8, and I'm going to change this from being a green wire to a red wire. And then I'm going to connect my negative pin to my ground. Okay, and we're going to change that to be black. Okay. Okay. So that's all the wiring that's necessary for this. You could put it in a breadboard if you want, but you don't have to. So let's go to code here and make sure that we're in our text code. And if we go back to the Arduino website here, okay, right here, the code is right here. So we're just going to grab this code. Okay, so we're going to highlight all of this. I'm going to talk about this code in more depth here in a second, but we're going to copy all of that code. Notice there's nothing in the loop in this particular one. We're going to come back to Tinkercad, delete anything that's in here for right now, and we're going to paste this. So let's kind of talk about this code. Well, actually, let's get pitches.h in here first before we go and do that. So pitches.h, if we keep going down through here, it tells you that you're going to create a button and go through this new tab stuff, except we can't do that. So this is what we're going to do instead. Is we're going to copy everything here from the top of our public constants all the way down to the bottom of this, okay? So these are all of the frequencies that every note is going to have, okay? So like a C note in the fourth octave has a frequency of 262 hertz, okay? Which means that it's going to oscillate 262 times per second to make that note. I'm going to copy this, and I'm going to bring this over to my code. And you see right here where it says include pitches.h, that would refer to that tab that we're opening up in the real IDE. We're going to delete that here, and instead we're going to paste all of this definition right in here. Okay, so I've replaced that, include pitches.h. I've put all of my constants in here. These are all my notes. And if I go to start my simulation, you should hear the song. Okay, so if I start that again. So that is our familiar tune that we're going to start off with, right? And again, it's like da 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 da. So when we come back here to my notes, which of course, just like always, these notes are posted on Classroom itself. So here we copied our base code, we copied that into Tinkercad, we inserted our pitches.h differently, so you're going to check out that video for more information. And we just tested our code, okay? So after successfully putting in your code, you should hear that familiar tone. If it doesn't work, review the video, try it again. So let's talk about breaking down the code itself. So at the beginning of the code, like if we look here, this is just basically broke down from the top down. Okay, so at the beginning of the code here, we have this integer melody. Okay, and this is what's called a string. And down in our void setup, we have a for loop, and it says for this note. Okay, and this note is equal to 0, and this note is less than 8, yada yada. So when we're going to count, well, for our for loop, we're going to count from 0 through, in this case, 7. Okay, so when we go to set this up here, every time we go through, our note is going to increase by 1. So when we come down to tone, we have those 3 areas, okay? We have the pin that we're going to write the code, the song, the note to. We have the note itself, and we have how long the note is going to last for. So in order to come up with what note to play, it pulls this note, which is this integer. And this note is either a number 0 through 7. So this note is going to be the first time through 0. Okay, and what this is really referring to, this is referring to the string above. Notice how this is in a square bracket, not a like curly Q bracket or anything else. And that square bracket refers back up to the melody string up above. And this bracket, whatever number we're calling, is going to refer to that note in this list here, in this string. So note 0 is C4, note 1 is G3, note 2 is G3, note 3 is A3, note 4 is G3. Note 5 is a rest, which means that there's no note at all. Note 5 is B3. Note 6 is C4. And then it goes into, let's see here, did I miscount here? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I'm sorry. So this is 0, 1, 2, 3, 4, 5, 6, 7. And because this note stops at when it's less than 8, aka 7, it's going to stop playing at that point there. So first of all, let's take a look at these notes and let's discuss them a little bit further. So again, we have all of our notes up here. 0 is a rest once again. So this section has all the notes for our song. Okay, the 4 that's listed here, the 3 that's listed here, and the notes refers to the octave. There are only 8 notes in music. Note A through G. There's sharps and flats in between there. And I'm not really a music person myself, so I'm certainly not a great source of information on musical structure. But there are only 8 basic notes, okay? But there are multiple octaves of notes. So the higher the octave is, the higher the note is, okay? So a C4 note is higher than a C3 note by 1 octave, okay? They're both C notes, but they're an octave different from one another. And if you were to like imagine a keyboard like a piano, and you think about all of those keys starting at like the really high pitch and going down to the really low pitch, you have your higher octaves at the high pitch and your lower octaves at the low pitch. But there's only groupings of 8 notes A through G going down through there. In the next section, we have our note durations. And again, this is another string. And these are fractions, okay? So this section includes our note length. Each of these numbers in this are the denominator of a fraction. Okay, so for instance, this 4 here is really 1/4, okay, the denominator. So it creates a 1/4 note, while the 8 is a 1/8 note. Okay, if we had the number 1 in here, it'd be a whole note. If we had the number 2 in here, it'd be a half note. So each of these numbers refers to their note above. So again, this is going to be 0, 1, 2, 3, 4, 5, 6, 7. So C4 is a quarter note, G3 is an eighth note, G3 is an eighth note, A3 is a quarter note, G3 is a quarter note. Our rest is also a quarter note, B3 and C4 are all quarter notes as well. So when we look in the void setup, okay, we're only running this code in the void setup because it's not going to loop. It's only going to play once. Once again, we have this for loop, which is going to define our string. So for integer, this note, it's going to start at 0, and it's going to go up to, in this case, once it counts to 7. So again, that's 8 total notes, 0 being the first, 7 being the 8th. And every time we go through, we're going to increase this note by 1. Down below here, we have our note duration is equal to 1,000. That's 1 second, basically, divided by your note duration. Okay, so this is where we're going to create the fraction, basically. We're going to say, well, 1,000 divided by 4 is a quarter note. 1,000 divided by 8 is an eighth note. 1,000 divided by 2 is a half note. The shorter this number is, the faster the rate of the song will progress. Basically here, 1 second is referred to as a full note, where like half of a second would be a half note and an eighth is an eighth, so on and so forth. So then again, we go into our tone function, which again has 3 parameters to it. The first one is the pin. The second one is what note we're going to play. So melody, this note is going to go back to the melody string, and it's going to reference what number this note is. Okay, so it's going to say melody 0 to start with, which would be C4. And then it's going to play the note duration, referencing the note duration, which is found right here. Okay, it goes to note duration and then this note. So this note here also is referring to that 0 through 8. So it's already calculated that the note duration for C4 is 1,000 divided by 4, or 250 milliseconds. So this is going to be replaced by 250 milliseconds. I'm going to pause in between our notes. You don't really need to edit that too much, and this actually creates that pause. And then no tone 8 is going to stop playing music on pin 8, which is going to essentially stop that particular note. Then we're going to go back through the for loop, and then this time this note would be equal to 1. So that would refer to note G3 and note duration 8, and it would repeat the process. One thing too to note here is that when you play Twinkle Twinkle Little Star, the 8 is really the thing that like stops the song being played. Okay, it's going to stop counting up in the string. So you're going to need to change that. Excuse me. You're going to need to change that later on, and we'll talk about that in the next slide here. So Twinkle Twinkle Little Star is as follows. Okay, we have C note, C, C, G, G, A, A, G. You guys can read through the rest. Okay, but this is each line, like Twinkle Twinkle Little Star. Okay, I know I'm excellent at music, at singing. So when we look at Twinkle Twinkle Little Star, we have the C is a fourth note, the C is a fourth note, the G, the A, they're all fourth notes, and then that last note there is a half note, okay? When we go through here, I wish I could make this go away. Let's see if, so in the bottom here, which we cannot see, let's see here we go. So note that there are 22 notes in this song. Okay, so for the for loop, you know, this section up here, we're going to need to change this note to be less than 42. Okay, so this note less than 42 for Twinkle Twinkle Little Star. So let's just go through like the first line of code here and together as a group, and then we will play that, and then I'll show you what the end is going to be. So first of all, I need to know how many notes there are. There are 1, 2, 3, 4, 5, 6, 7 notes. So I'm just going to play this first little section. And again, when I start to look at those notes, they're C, C, G, G, A, A, G. And it doesn't mention anything about octaves. So what I would suggest to you is to just stick to the same octave to begin with, and then edit your octaves as you go through. So we have C, C, G, G. So I'm going to name all of these. And like the fourth octave is a nice central octave. So we have C, C, G, G, A. We're going to replace the rest with another A. And then the last one here is going to be a G4. Okay, so notice I'm going to get rid of this stuff here. Now, when I come down to my note durations, okay, these are all quarter notes. So I have C4 is a quarter, C4 is a quarter, G4 is a quarter, G4 is a quarter, A4 is a quarter, A4 is a quarter, but then the last is going to be a half note. Okay, so that last G note is going to be a half. And again, I have 1, 2, 3, 4, 5, 6, 7 notes at this point. So I'm going to change this note to 7 for right now. I'm going to start my simulation. Okay, so that was my first line of music. When I go to create my next here, I'm going to put a comma between my notes. Okay, each one of these notes is separated by a comma. I'm going to put a comma in between my notes, but then I'm going to jump down to the next line to work on my next set of code. Remember, copy and paste is your friend here. So we're going to go note F4, F4, E, E, D, D, and C. Okay, and the note durations are going to be the same for each one of these. So again, I'm going to put a comma at the end of my next line. I like to separate out my lines just to make things like easier to read. I know that this line of notes goes to this line of notes and so on and so forth. So when I start my simulation now, so notice I still played the exact same song that I had before, and that's because my note duration hasn't changed, okay? My note duration needs to go up by the number of notes that I have here. So I have 7 notes in my first line, 7 notes in my second line, so I have 14 notes in total. So now when I start my simulation, okay? And you're gonna go through and you're gonna finish up Twinkle Twinkle Little Star till it sounds something like this. So in the end, your song should sound something like this. Okay, make sure that at the end of your strings you don't have commas. You shouldn't have a comma like at the end of either of your melodies. Oh yeah, I can show you in the code here. So like, let's see here, not that one, this one here. Make sure that like at the end of your melodies, right, in between your notes, you have commas, but the last note is not going to have a comma after it. Also notice that these strings, there's a curly Q bracket and then a semicolon. So if you delete that on accident, that needs to get added back in again. Note durations also, note that there's no comma on the last one and that there's a semicolon and a curly Q bracket here at the end. Okay, so once you have completed this stuff, again, when we go back to our objectives, you are going to share your Twinkle Twinkle Little Star song with me, and that will take care of your assignment for this week. Okay, if you guys have any questions, email me. Actually, one real quick here, one trick that I've learned throughout something is like, let's say that I don't have a semicolon here. So let's say I forget a semicolon there and I go to start my simulation. It's going to tell me my error. It's going to say, well, you have an error in your void setup and you're expecting a semicolon, okay? But what's neat about this program is it actually tells you exactly what line it is, okay? So it's line 146 that I have my error with, okay? So 146, but it's not actually 146, it's the semicolon that comes before line 146. So it's actually the semicolon that I just removed from there, and that fixes that problem, okay? So again, send me your Twinkle Twinkle Little Star song, email me with any questions. Make sure to like the video and subscribe, and we'll talk to you guys soon. All right, have a great week. Bye-bye.